All right, we're going to start the new unit on probability, and we're going to start with something that we're a little bit more familiar with, with geometric probability, where we're finding shaded regions, and then we're finding the probability of landing in a shaded region. The way that I like to look at this is, if you've ever played darts before, it's like a dartboard. What's the probability if we're blindfolded, right? We're not aiming. This is completely random. What's the probability that we land in the shaded region if we throw a dartboard? So, like, for example, if this was my problem, it's not what we're doing on this first one, but if that was my problem, what are the odds that I land my dartboard in one of these? Oh, not that one, not in the circle, but in one of these locations, right? That's what we're looking for in these types of problems that we're going to go through today. But to start, we have a little warm-up. So if the substitute, or if you're just watching this at home, if you pause the video now, I'll give you a couple seconds to find that shaded region, and then the second part is to change decimals into percentages, which is something you haven't done yet this year, but you've done in the past. So I'll give you a couple seconds here to start if you want to pause the video. Okay, now we can go through these questions. So for letter A, find the shaded area. This is one of those problems where we're going to do outside minus inside. My outside area minus my inside area. My outside area is a rectangle on this one, and my rectangle formula is base times height. I noticed that this is 16, so that would mean the diameter of this circle is 16, which means we've got 16, 16, and 16 going this way, which means we have 48. Oops. 48 across, so I can do my outside as 48 times 16, and then my inside is 3 circles. My circle formula is pi r squared. Well, my radius will be 8 for each of those circles, and I'm just going to do them all at one time. So I'll do 3 circles. This is the big thing that people forget, that 3 right there. But if I do 3 circles, that's 3 of my pi r squareds. Pi times my radius was 8 squared. And then I could just type that all in at one time on my calculator. And in fact, I will need to do that. So give me 1 second. So 48 times 16. And then minus 3 times, I'm going to do the pi button, but you guys might have used 3.14, so maybe you're going to get something a little bit different, but then I'll multiply that by 8 squared, and I'll get 164.8. If I round to the nearest tenth, that's what it's going to be, and then we don't have, oh yeah, we do have units, that'll be meters. So my shaded area is 164.8 meters, and we're going to use this a lot today. But just so we're aware, that's all of this shaded spot, or shaded parts of that picture, which is something we'll work with a lot today in the lesson. Let's talk about percentages. If I'm changing these into percentages, the rule is if I want to go from decimal to percent, I have to move it 2 to the right. So 0.75, if I move the decimal over here, that's like 75%. This decimal is a little bit different. If I move 2 to the right, the decimal still goes in front. This is like 0.75%, which is less than 1%. That's a very small percentage. The last one, if I move twice to the right for the last time, that is going to be 7.5%. And so yeah, that's how you do those. Move them 2 to the right to move them from decimals to percentages. All right, our understanding goal today is that we understand the concept of finding probability, and then we're going to do that, like I said, with shaded regions today, but I like to call these dartboard problems. So probability, it is the percent chance an event occurs. So the percent chance that something happens. The largest probability that we'll work with, I mean, you can't have a higher percent chance of something happening than 100%. Like, you can't say you've got 120% chance of something happening. 100% is a for sure thing. Or if we wanted to display that as a decimal, that would technically be 1. If we move the decimal 2 to the left, that would be a 1. So it says a dart hits the square dartboard, as shown below, at a random point. Find the probability that the dart lands in the shaded region. So again, this is like blindfolded. We're throwing at random. There's a good chance that you'll hit outside of the circle, but it wants to know what the probability is that will hit inside the circle. So the first thing we need to do is we need to find the area of both of those. We need to find the area of the total shape, which is something that we're pretty good with. This says it's a square dartboard, so I'm going to put a 7 there because that's what a square would look like. My total area shape is a square. The formula for that was side squared or base times height. And then if I wanted the actual number for that, it's going to be 7 times 7, which is 49. The shaded area for the inside is going to be a circle. Formula for that is pi r squared. And then if I do that, that would be pi times 2 squared. And then the probability for this, the way that you got to think about all of these questions, you got to think about them all the same way. It's going to be your outside divided by, I'm sorry, I did that backwards already. Let's try that again. Oops, there we go. It's going to be your, actually I'm going to change it up. I'm going to call it win divided by total. So what would be considered a win on this problem? Well, the win would be that circle. And we said our circle area was, not that one, our circle area was this one, which I didn't even come up with a decimal for yet. So that's going to be what? I'm going to do, it says use 3.14, so I'll do 3.14. 3.14 times, that's going to be 2 squared, which is 12.56. And when you do this on ALEKS, you will have to use 3.14 so that we don't have these weird decimals. But I'll get 12.56 for the area of that shaded region. That's what we would consider a win. A win would be hitting your dartboard in there somewhere. So 12.56 would be considered a win. And then total would be the outside shape, basically. So that would be 49. The area of that square was 49. Once I divide that, I will get 0.25632, something like that. So as a decimal, that was 0.2563, something like that. So that percentage would be about 25.6%. I guess that percent can go on the back. Just like that. Next one. Total area shape is a circle this time. Our formula for the circle is pi r squared, and I'm just going to put the formula right in, like with the numbers and everything, right in that formula line from now on. So my circle is pi times radius squared, but my radius is 18. I'm going to do that right away. 3.14 times 18 squared is 1017.36. My shaded area is a square. And then my formula for the shaded area, since that's a square, that's a 6 by 6. So it'd be 6 times 6, which equals 36. Okay, and then I can do my probability. Remember, I'm going to use the same formula, win divided by total. That's an important formula for later too. We're going to use that like basically the whole unit. So win divided by total. My win would be considered the square. I have to hit it in the shaded region, which is the square. Those would all be considered wins. So 36. My total was the circle. That's the outside shape. That's going to be 1017.36. If I divide those, I got 0.03538 Actually, I'll just make it 9 if I'm rounding. That's where I'll round. And then the percentage for that, I'll just round to the nearest tenth on that. That'll be 0. Percent. We got to move the decimal. We got to move the decimal twice to the right to make a percent. So it'll be 3.5. I'll just keep it like that, percent for now. Which, if you look at the picture, it looks about right. 3.5% seems good. It's a pretty small area to hit. So you can always kind of gauge it from that. Now we're going to get into some tougher ones. It says find the probability that a point chosen at random lies in the shaded region. So these ones are a little bit trickier because if you look up top, if you look at what we're trying to hit the dartboard in, or the dart in, it's always this, like the shape in the middle that we're trying to hit, right? There's a big difference on these problems coming up. It looks to me like now we're trying to avoid the shapes that they're putting in the middle. Like I'm trying to avoid those triangles. I'm trying to avoid the circles over here. So this is a different problem. It doesn't work the same way as those last ones. Here's what we're gonna have to do. We're gonna have to find the area of the total shape, just like before. So if we find the area of the total shape, oh, this is a little tricky. I see that our hypotenuse is 5 there, but that hypotenuse is also the diameter of the circle. So really, the radius would be 2.5. So I'm going to use that in my formula here. The total area shape is a circle. This is pi times radius squared, which is 2.5 squared. I'll find that quick. I'll do 3.14 again, times 2.5 squared. Looks like I got 19.625. I'll zoom in a little bit on this one. Then it says shaded area combo. It says combo because we have to think about this a different way. If we want the shaded area, really what we're going to need to do is we're going to need to subtract out these pieces. This is like the cookie cutter questions from our last unit in Unit 8. You've done problems like this before. If we want the shaded area now, we're going to have to do our outside shape minus our inside shape to figure out what our shaded region is. So our outside shape again was the circle. I'll just do the 19.625 minus our inside shape, but again, we have 2. So I'm going to go up here next to the circle and show my work on this. So for one triangle, we have a hypotenuse of 5. It says this is 4, and it doesn't have it there. But that we do know that this is a right angle. This actually goes back to our circles unit. If we have marks on the corners, or if we have points on the corners of the circle, this will always be a 90-degree angle. And with that being a 90-degree angle, I think we might be missing some information on this, but this is supposed to be a length of 4. The other thing that we know about this triangle is this is also a radius. So if that's a radius, then that would be 2.5, and this would be 2.5 on this side as well, because that's also a radius. So we have 2 triangles. My small triangle would be 2.5 times 2.5 divided by 2, right? Base times height divided by 2, if that's a right angle. This times this divided by 2. So 2.5 squared divided by 2 is 3.125. So the area of that small triangle is that. The area of the large triangle is 4 times 4 divided by 2. I can do that in my head. 4 times 4 is 16. Divided by 2 would be 8. So if I add those together, we will get 11.125. If I subtract those, I guess I wrote that in the wrong spot. Maybe they should be down under formula. And in the shaded area combo, you should write 2 triangles. But anyway, we'll just do it here. If I subtract those, we'll get 19.625 minus 11.125 to equal 8.5. And 8.5 is the area of the shaded region. We're still not done yet though, because we have the area of the outside, we have the area of the shaded. Remember, a shaded would be considered a win. If my dartboard, or if my dart hits the dartboard on the shaded, I win. So my formula for probability, once again, is win divided by total, which means we'll have 8.5, I don't know if it has a label on there, units squared to hit my dart on, divided by the total, which is 19.625. If I divide those, I get 43.3%. I've already moved the decimal on my calculator twice to the right, but this is somewhere around 43.3%. Okay, let's do the next one. Number 4. My total area shape, or the entire shape, is a rectangle. We've done problems like this before. If we know that the radius is 3, that means the diameter is 6, and we have 3 of those. So the whole length across would be 18. And then the same thing here, if the length of my diameter is a 6 going the way down, all the way down, that would be a length of 12. So my shape, my rectangle, would be 8 times 12. 18 times 12 equals 216. Okay, the shaded area combo. In this case, it says combo again. It's not going to tell you this on the semester test or on the chapter test. Like, that's something that we'll have to kind of come up with on our own. The shapes in the middle are like what we don't want to hit. Like, those are wrong. If we throw our dart, or incorrect or whatever, they're a loss. If you throw your dartboard or dart at the dartboard and hit the white part. So my shaded area combo will be the outside minus the inside again. So my rectangle minus my circles. I already have my rectangle as 216. My circles, I have 6 of them. It'll be 6 times pi times my radius, which we said was 3 squared. So I'll type that in. We'll do 3.14 again. 46.44 is what I got. So one more time, that is the area of the shaded part. That would be considered a win. So then when I do my probability, it's win divided by total, which would be 46.44 divided by 216. And then I'll have to figure out what that is. Looks like I got 21.5%. Okay. What do we got? 2 left. Yeah, we're going to be doing regular polygons once again. So let's do the first one. So number 5 says total area shape. That's a circle. Our circle formula is pi r squared. My radius of the circle looks like it's 10. I guess I can write that in. I'll do 3.14. I got 314. Duh. That makes sense. Shaded area combo. So this, again, is outside shape minus inside shape because we're trying not to hit the shape that's on the inside. So we have to subtract. So my outside shape is a circle, which was 314. I guess I can write circle. Minus. Do we know the shape on the inside? That is your regular polygon. So my circle, we said, was 314. I'm subtracting off my regular polygon, which is 1/2 PA. I'll have to do a little bit of extra work up here. I'll do my triangle right there. So if that's 10, this is 5 with my 30, 60, 90 triangle, which means this is 5 root 3. So 1/2 my perimeter would be 60, I believe. If that's 5, this is 5. Each side would be 10. So that would be 60 for my perimeter. And my apothem would be 5 root 3. I'm gonna type that into my calculator now. So 314 minus 1/2 times 60 times 5 times the square root of 3. And I got 54.19237, something like that. It goes on forever. I didn't round yet because I don't want to round till my final answer. Probability, win over total. A win would be that shaded region, that 54.19, divided by the circle, which was 314. If you look at the picture, it's a pretty small chance that you hit there, so we should get a pretty low number. We'll see what we get. Divided by 314, I got 17%. I'm going to round up to 17.3, which seems about right. A 17% chance is pretty low. Number 6, total area shape is a square. The formula is 20 times 20, which equals 400. The shaded area combo is the outside minus the inside. I don't need to write that out. I can do square minus circles. Capital S at the end of that because there's multiple. My square was 400. I have 4 circles, so I'll subtract off 4 pi r squareds. I guess I know my radius, huh? Or I have to figure it out. So if the whole way across is 20, that means the diameter would be 10, which means my radius would be 5. 400 minus 4 pi. I'll do 3.14. Times 5 squared is 86. Okay, and then my probability would be 86 divided by 400. Which is 40, well, it didn't give me a decimal. Hold on, Control Enter. Gives me a decimal. 0.215, which is 21.5%. Looking at the picture, does 21.5 look correct to you? It looks right to me. It's a pretty low chance to hit one of the shaded parts on there. Okay, you have one ALEKS topic, and I gotta preface this before you guys get into your ALEKS topic. Your ALEKS topic is area probability. ALEKS topics will look like these. These are not a good representation of what is on the test. These questions, we didn't have to do any of this extra work here where we had to subtract on those problems. Like we had to subtract to figure out our shaded region, and then we had to solve from there. These problems, it's just the shape that's in the inside. The semester test and the chapter test will not have, they'll maybe have one of these, but they will mostly have these. I know for sure that these are on the chapter test and on the unit test, so we do need to understand these. We will be doing some quizzes with these eventually this week or next week, but at least you'll get a little bit of practice with these, a very basic start to these problems on ALEKS, and then we'll keep going with them in the future. Okay, good luck on ALEKS, and yeah, let me know if you have any questions.